Next is functions. Functions are a special type of relations these may be one type of relation or many one type. A relation of one to many type cannot be a function. Similarly, many to many type of relation is also not a function. We represent the function as f x to y. Here, this x is the domain of the function. Suppose an element of the domain is x, so x belongs to domain. And y is the codomain of the function. And if y is the element of codomain y, we represent y belongs to y. And set of elements y which are images of any of element in domain is called range of the function. So here we can say that y is the image and x is the preimage. And we can write that y equal to fx. Let's take some examples. First example is, if set A has element 1, 2 and 3 and fg are the relations corresponding to the subset of Cartesian product A cross A given by f equal to 1, 3, 2, 3 and 3, 2, while the relation G has the element 1, 2, 1, 3 and 3, 1. Which of f and g is a function? For function, we have to remember two important points, that each element in domain will have an image, and second point is each element in domain will have a unique image. Now we take first relation f, which has the element, they are in ordered pair 1, 3, 2, 3 and 3, 2. Here domain is the set A having the element 1, 2, 3. Similarly, codomain is also having the set A, that is 1, 2, 3. Range is the y element of the ordered pair. This is 3, 3 and 2. So range is 3 and 2. If we make the picture of this relation, we will have, this is the set A acting as domain, and another set is also A which is acting as a codomain. This A is domain and another A is codomain. And there is a relation between this A to A. Domain has three elements, 1, 2 and 3. Codomain is also having the three elements, 1, 2 and 3. And mapping is 1 is related with here 3. So 1 and 3 are related. Then 2 is related with 3. And after that 3 is related with 2. So this is the 3. So from the diagram, we see that every element of domain has some unique image. So it is the first point, second point, which is satisfied, and all element of the domain have some images. So first point is also satisfied. Therefore, f is a function. Now we take the diagram for the second relation, which is G. Again, we have the domain, which is set A, and set A is also the codomain, and there is a relation from set A, that is domain to codomain, and it is G. Here elements are 1, 2 and 3, and codomain is also having the element 1, 2 and 3. Now we map the elements with their images. So G has the first element 1 and have the image 2. So 1 is related with 2. Then in second case, 1 is related with 3. So 1 is also have one of the image, that is 3. And then 3 is related with 1. So 3 has the image 1. Here we see that 1 in the domain do not have the unique image, but it has two images, 2 and 3. So it is not a function. Again, the element 2 has no images. So we can say G is not a function because 2 has no image and also 1 is not having the unique image. Second question is, if F has the two ordered pair as its elements, they are 5 and 2 and 6 and 3. Write the range of the function. Here we know that range is the set of the y element, that is the second element or of the images. So we can say that range is the set of images that are 2 and 3. Third example is, the domain of the function f R2 are defined by function root x square minus 3x plus 2h. We are given the function is root x square minus 3x plus 2 and domain is the set of values of x for which function definition is true. So to have the real values for the function, the argument inside the square root should be greater than equal to 0. So we can write that x square minus 3x plus 2 should be greater than equal to 0. Because if it is less than 0, it will give a complex number which is not a real number. On solving, we will have, first we make the factors. So it is x minus 1 into x minus 2 greater than equal to 0. And using the Weber method, we draw the number line from minus infinity to infinity and mark the roots of these two polynomials. So we will have x equal to 1 and 2. So it is 2 and it is 1. And now we draw a curve like as we are drawn here. And because it is greater, so we will take the values above the number line. This is the positive values. And greater than equal to, for equal to, we will take the values 1 and 2 also. So we will mark here solid circle. Therefore, our solution will be the air shaded area. That means x belongs to minus infinity to 1 and 1 is inclusive. So we will put a square bracket, while minus infinity is non-inclusive. So we will put a parenthesis and then union, and it is 2. 2 is inclusive, so square bracket and then infinity. This is the answer. This is the domain of the function.